We have gone through a brief explanation and overview of what our project consisted of. What were the building blocks of TinyML and the ESP32 Sense device. So, you have, I am sure, listened to all of that. Now, the best way to learn all this technology is primarily by designing a project, working on a project. So, what we are going to do is, we are going to take you through a project which is fairly involved and sufficiently complex. It can be done in a couple of hours or maybe 3 or 4 hours, and then we are going to leave you with an exercise which you should attempt as an enhancement of that work. So, that way you get a grip on what the project entails, how is it being done, what is being done and all of that. So, let me start with what project we are trying to do. It is a pretty elaborate project, but should give you a lot of insight. So, the project is to do with gesture recognition. So, the first part of the project will teach our device using TinyML and training. It will teach our device what is it that it is to capture a gesture. For example, we may have a gesture which is like this, which will make it go forward, or we will have a gesture which is like this, which will go left, or we may just say L, we will say the letter L like this. That will be a gesture which will make the object move to the left, and then we might have a gesture which says R or R, which makes the object move to the right. So, we are doing a bit of gesture recognition. So, basically our primary goal of the project is to recognize gestures which our wearable device will recognize. So, there is the gesture recognition piece which is built to recognize a gesture. Let me talk a little bit about how this is going to happen. So, we have our device which is, let us call it device. We know what kind of device it is. It is an ESP32 Sense device with a bunch of sensor. So, first what we are going to do is, we are going to enhance this device. The standard sensors which our device has are a camera, a microphone and a touch screen. Now, we will enhance our device by connecting IMU, inertial measurement unit, which will allow us to measure the acceleration and the movement of the device. So, we are going to connect a 6050 IMU inertial measurement unit 6050, that is what we are going to connect to this device. We are going to enhance the device, connect IMU 6050. So, this will help us measure the accelerometer. It acts as an accelerometer. It will help us measure, and a gyrometer. It will help us measure the what you call the pitch, the yaw and the rotation. So with that we will be able to understand the gesture. A series of a gesture is basically, if I say L, it is a collection of various movements. So, all of them will be captured. So, we will first enhance the device with this. The communication between the device and the IMU 6050 is going to happen using I2C communication, which is the integrated IC communication. So, that is what is going to happen. Now, why do not I show you the device which is a collection, which is a combination of these two. So, I would like you to focus on this device. I think the camera will focus. So, this portion is the IMU which has been connected to my original Sense device. So, they have been kind of soldered together. So, this IMU enables me to become a gyroscope and an accelerometer. So, without that I will not be able to measure the features of the gesture. Okay, so let me elaborate on this. How does this all work? So, we are going to enhance the device. It is with this IMU 6050. After that, what we are going to do is we are going to obviously calibrate this device. We will see how the calibration happens and all that. But besides that, basically this device and the accelerometer now actually becomes our new device. So, let me call it new device. So, we took a regular sensor, regular ESP32, added this using a I2C communication protocol, basically soldered this together, and now we have the device which can perhaps be trained to recognize gestures. So, now I'll just show you what all will happen. So, we will take this device and then what we will do is we will remember there is something called edge impulse which helps in my tiny ML development. So, I have this edge impulse software. So, what I am going to do is I am going to ask for a little bit of training on this device. That is, I am going to do this gesture about, let us say this is L gesture. I am going to do it about 10 times, and I am going to move this device 10 times, and whatever readings it gets. So, obviously the readings will have to come on a Windows machine or something. So, I will have to capture those readings which come from the device, and once I capture these readings, so what will these readings look like? The way these readings are going to look like is it is going to be a collection of x, y, z coordinates, and which is a collection of those coordinates, those movements, and I am going to label them as left. Then I am going to do some more action and label them as right. So, this training data along with the labels, I have to be able to transfer it to edge impulse. So, I hope you are getting what I am trying to say. Now, why am I doing that? Because I want the software or the device to recognize and capture the gesture that I am making, and then I am going to make something happen based on that gesture. Some movement or of something happen based on that gesture. That is why all this effort is there. So, basically now I have created the new device with the accelerometer, I have calibrated it, and then I have made it, I have done this gesture 8 or 9 times, and after having done that gesture 8 or 9 times, I have got the readings and labeled it with that gesture, and now send these readings to the edge impulse software. The edge impulse software basically does the training of various gestures to be able to recognize the letter L from the letter R, and there may be other letters which I might ask you to train. So, we do the training. So, the model gets built on the edge impulse. Now, in order to be able to do all of that, here for example, I have to program the device to talk to the accelerometer, I have to make it give readings, I have to make it do a whole bunch of things. So, I will also need an Arduino IDE to work with that device. So, I load my laptop with the Arduino IDE, connect the device to it, so that I can instruct the device to do a whole lot of things, like calibration has to be done, like for example data forwarding has to be done, data forwarding to edge impulse. So, I need control on my device, and that control I am going to get through the Arduino IDE, and for the Arduino IDE to talk to the device, again the serial port is going to be used. So, we need to configure the serial port. So, the Arduino IDE which runs on the laptop has to be configured to run with this device, and in order to be able to do that, the communication happens through the serial port, which is nothing but the USB which is connected to the UART of the device. Remember, when we had looked at the block diagram of the device, I had shown you that there is a UART sitting there. Now that comes in pretty handy when it needs to come under the control of the laptop's Arduino IDE, so that I use this IDE and I program on this device. So life becomes easy and very structured. And therefore, I also told you why am I going to use edge impulse. I am reiterating that once the device is been asked to program for a gesture, I pick up the label for that gesture and the training data and I transfer it to edge impulse, which does the training. So the model training is happening offline, that is not happening on the device, it is happening on edge impulse on their site. So they are using their compute power and doing the training, and once the model has been approved or model has been done and tested or validated, the model is going to come back to my Arduino IDE as a program, as a model, as a library. It is going to come to me as an Arduino library, which I can use via my Arduino IDE. So it is coming back as a library. What does the library represent? The model. Where has the model been created? On edge impulse. How it has been created? Using the data which I supplied. How did I collect the data? Using the accelerometer connected to my device, I collected the data. And how did my device communicate with the accelerometer? Over I2C. So I have tried to put the pieces together and reiterated that. So where are we now? So now we are at a particular point where our ESP32 as a whole, along with this training and all, can recognize a gesture. So if I say L, it knows that the gesture the user is making is L. So when I take the variable and do L with it, it knows it is an L. Or if I do an R with it, it knows because of the X and Y coordinates it has gone through after, of course, proper setting or proper calibration, it knows that I have done a gesture like a left or a right. Now having done that gesture, what happens after that? Something has to react to that gesture, otherwise how do I know what use is this gesture? So for that we have put something interesting. So what we have done is that a lot of the people on our campus do a lot of drone programming. So we thought, let this gesture get converted into some kind of a command for the drone, which will then dictate the drone to move on the left or on the right or on the top or on the bottom. So we are going to control the movement of the drone from our wearable device, and of course we are not going to do the actual drone, because that would mean we can actually do it at some stage and probably we will demonstrate it also at some stage, but right now we are using a simulator. So we are using a drone kit simulator. So here we have the drone kit simulator, which runs on a PC or a laptop. So we have the drone kit simulator. It is called the drone kit SITL, which stands for the drone kit simulator. So that is going to run by itself as a server on another either on the same PC or on a different PC, does not matter. So I am having a drone kit simulator. Now you will ask, what does it do? It basically shows a drone which is immobile. The drone is not doing anything. The drone is going to respond to my gestures. As of now, the drone kit simulator has a drone but does not show any movement on the drone, does not go anywhere because it has not received any commands. Now the way it is going to now happen is, my software which is running on this device, on the ESP32. So this device is the ESP32. Now that is going to talk to the drone simulator, but we are going to use a proxy here. So let us call it a proxy. It is called the Mavlink proxy, Mavlink being the protocol which is used, but we will get to the details in a moment. in a little while, but at the moment the drone kit is under the control of a proxy, and the proxy is being I also have a server program which is a web server kind of program. So, let us call it a web server kind of program, basically an HTTP based program running at a specific port, which runs which has ability to talk via a proxy to the drone kit simulator. I hope this setup is reasonably clear. This is being done on another machine, not on the ESP32 obviously. What all do I have there? I have a server program which is going to receive instructions from the ESP32, and it is going to talk to the drone kit simulator via a proxy. So, that is the setup which I have here, and then I have the ESP32, and now what I am going to do is I am going to develop a program on the ESP32. Now, let us talk about the program and let us talk about how the program is going to talk to that server program. So, you can think like this, that the client program we are going to develop is on the ESP32, and how am I going to develop it? I obviously can't develop a program on the ESP32 on that tiny device. Obviously, I am going to do it on the Arduino IDE, and the program is going to be deployed onto the device, on the wearable device, on the ESP32S. That is the Seed Studio Sense device which we talked about earlier. So, now what is going to happen is that once I okay, so let us talk about this program. What is this program going to do? I know the screen is starting to look cluttered, but that is the whole idea. So, the program is going to do this, the client program as I call it. First, it is going to read, it is going to do a bit of I2C programming and read the gesture, or I won't say read the gesture, read the XY coordinates for a few seconds. XY coordinates from whom? From the IMU 6050, which is the device attachment, which is going to give me information about the movement of the device. Is it doing an L, is it doing an R, or is it doing another gesture? But as we will do this gesture, imagine we will do this gesture, but the gesture data, that is the X, Y and Z coordinates of the gesture, have to be captured. So, these so the first thing this program is going to do is capture the X, Y, Z coordinates from the IMU. It is going to capture that. Now, does it know what these coordinates means? Does our program know what the coordinates means? Absolutely not. It does not understand this. This is just a bunch of movements which have been captured. There are a series of XYZ, by the way. So, it does not understand any of these. Now, okay, there is a small point which I should have mentioned during training, but does not matter right now. So, the XYZ, a series of XYZ related to my gesture have been captured by my program, my client program. Once those are captured, it does not understand the gesture. So, now what does it do? It goes, remember, it has got the ML program, the ML model which it has been trained from the edge impulse. So, it gets the model, it has already got the model. So, it uses that model to now determine, based on the gestures which it has captured and based on the model which has been already trained to understand some of these gestures. So, it will ask the model to identify the gesture, Now, once the gesture is identified, which may be left, right, top, bottom, whatever it may be, or forward, backward, it could be any, we can predefine those gestures. So, once the gesture has been identified, now the gesture has been identified at the ESP32 level. I have written a program to do that, but it is no use sitting here. The gesture has to be communicated to the place which is in control of the drone, so that the drone will shift according to my gesture. So, if I have said left, the drone will shift to the left. If I have said right, the drone will shift to the right. If I have said up, the drone will go up. If I say down, if I gesture down, the drone will go down. But all of that has to happen there. Now, how is my ESP32 going to talk to a program running on the server? Well, as I showed you earlier, our smart ESP32 has two kinds of communication. It can support Wi-Fi or it can support BLE, that is the Bluetooth communication. We can use either of them, but we choose to use Wi-Fi, and that is the physical link, and the communication protocol which we are going to use is called the WebSocket protocol, which is a socket level protocol which runs over the Wi-Fi link. So, we have that. So, this guy is going to use the WebSocket client, and this server program obviously has the WebSocket server. So, it is listening using WebSockets, and this program is going to send via WebSockets. So, it is going to send the command identified by the gesture, which is left or right or whatever. This command is going to be sent to the server. The server is then going to talk to the simulator via the proxy, and then the simulator is going to show how the drone is going to move up and down. So, the language it is going to talk here is the Mavlink kind of language, because that is what the drone kit understands. It does not understand up down. There is a specific way those commands have to be communicated. So, there are various pieces in this program. There is first of all this attachment of the accelerometer. There is the training of the gesture. First, of course, the calibration of the accelerometer. After that, the training of the gesture, that involves edge impulse and also capturing the gestures, using it for training, getting the model back, which is a tiny ML model, putting it onto the ESP32. Then comes the actual inferencing, that is recognizing the XYZ coordinates of the actual gesture which is made, converting those coordinates, using the model which has been done into a gesture, then communicating the gesture to the server side, and then the server side using a specific drone kit API or the Mavlink API in order to talk to the simulator and making it move or follow the gesture. So, basically it has to do the action related to the gesture. So, this is the whole project which we are going to soon demonstrate, and we are going to demonstrate what pieces of software you need to install in order for this to work.